Okay, y'all, I got new lights hooked up, so maybe this will be a little easier to see. This is a problem that a student asked me to go over from test chapter number 4, problem number 10. Now, problem number 11 is something that we've never gone over. Residuals, just ignore it, don't worry about that. Maybe I'll make a video of that, but it's something I skipped in chapter 4. Anyway, here we have the data. And I graphed the data from the problem number 10. This is the yearly attendance versus advertising costs. So can you get people to come out if you spend money advertising to them? You would think so. People see stuff all the time on TV and nowadays the internet. So if they see that, if you pay for that, if they see that, will that sponsor more people to come? And so you can see there is, if you plot all the data, an increase. So more spending on advertising does correlate with an increase in attendance, but how much? How much do you have to spend for a certain amount of attendance increase on average? Well, you can see the dashed line, that's the line of regression, or the line of best fit, or the trend line, which is probably more accurate. So the overall trend is the more money you spend on advertising, the more people you will get coming to whatever event you want them to come to. Leaving aside out here the Warriors and 49ers and Giants, it's you don't have to advertise, they're going to show up. But this is just in general. Anyway, so you can see, how do you get the equation of best fit? The line, the linear regression line. Well, I just took 2 points that seem to match the data well. Coincidentally, they're also the first and last points of data. Do not get the impression that's the case. There's not a lot of data here. Usually when you do this, you have about 30, 40, 50 or more data points. So it's more complicated. Don't think it's always the first and last data point. In this case, it just is. So I took that. You can see what I did over there. Alright, getting the slope, and now you get the simplification of the fraction, which is what I'm doing. A lot of y'all will just divide. So you get 0.02. Now remember, that's 0.02 per 1. And remember, the slope is always the change in the y over the change in the x. Right? You subtract the y's on top, you subtract the x's on bottom. Well, what's the y? Well, the y is the yearly attendance. And the x is the advertising cost. So in other words, the change in your yearly attendance over the change in your advertising cost. So when you get over here and you're talking about 0.2 per 1, that means 0.2 change in attendance per $1 ad cost. Well, okay, let's make that 2 over 100. That means for every $100, you can increase the amount of attendance by 2. So 2 more people will show up to your event if you spend $100 more. Anyway, you can see what's going on right here. I used point slope form, and this is the coordinate I used. And I used the fraction. Now what's the y-intercept mean? Well, the y-intercept means that you're going to have to start spending $390 before you get an increase in attendance. That's basically what that means, because when 0 is x, that, or rather, I'm stupid. I confused the x and the y. Y-intercept means you're starting with 390 people showing up, and you want to increase from that. So if you don't spend any money, 390 people will show up. I have loyalty, or for whatever reason. Okay, I hope this helped. Let me know if there's anything else you guys need. I have no problem making videos. As you can see, I already got it set up, and now I finally got a light source. So this is interesting.